Yeah, in this tutorial we are going to cover Pandas data frame. So Pandas data frame is actually a two-dimensional data structure. So you can think of it as like a tabular data in the form of rows and the columns, just like we have tables in any RDBMS data system, or we have a sheet in Excel where we have rows and the columns. So data frames exactly are like this in Pandas. So we'll start with this. So let's say we have data of couple of players, uh, which is basically a dictionary. If you see now, the data where we are capturing is the player name, the matches the player has played, their test batting average, number of centuries they have scored, and the runs, total runs they have scored in their career. And IDX is INDX is a list. It basically indicates the country to which the player belonged to. So what we are going to do is we are using this data and index. We are going to create a data frame. So the way to create a data frame is PD, which stands for Panda. So PD dot data frame, and then we specify data. So data equals to the data that we are going to use to build the data frame. So this is actually a dictionary, okay? And index is basically the row labels that we are going to specify once the data frame is created. So we are saying index is INDX. So the data frame DF gets created. So if you see, it looks like this. So it's in a tabular format. We have columns. So these are the columns which basically match with the keys that we specified in the dictionary: player, matches, batting average, centuries, runs, and this is the entire data that we have given here. The values of the keys is actually the data here, and in the index we specified the country names. This serves as a row labels or row index for this particular data frame. Yeah, so the columns are the name of the columns and the row labels are the index rows. Now if you want to see for any data frame how many columns are there, we can just simply say df.columns. It will list out all the columns of the data frame. So it is having player, matches, batting average, centuries, and runs. So all the columns are listed here. To display the labels of the rows, so we can say df.index. So all the index row label index labels are displayed. Once the data frame is created, one thing we have to do is we have to find out the shape of the data frame. So basically what we want to find out is how many rows and columns are there. So we say df.shape. It will give you the result in the form of a tuple. The first value indicates the number of rows and the second value indicates the number of columns. Now how much memory the data frame is occupying, we can find it out using memory underscore usage function. So we say df.memory underscore usage. So it will tell how much memory in the bytes each particular column is occupying. Once the data frame is created, if you want to see the initial few rows, we can say df.head, and we can specify the number of records we want to see in the head by saying n equals to 3. So it will display the first three records of the data frame. Default value is the 5, so if we don't specify any value here, then it will display the first 5 records. Similarly, we can use the tail function to display the last n records. If we don't give any value, it will display the last 5 records. Otherwise, whatever value we give, it will be displayed. Now, to check the data type of the columns, we use df.dtypes. It displays the data type of all the columns. For example, player is object, that is its string type. Yeah, matches is integer 64 because it's numeric. Batting average is in the float. Centuries is again integer, and runs is again integer. We can capture the statistics related to the particular data frame using df.describe. So it will tell the count, that is the number of values that particular columns are having, what is the mean value, the standard deviation, minimum 25, 50, 75 percentile, and the maximum value. So with this we get an overall idea like how the data is distributed within each column of the data frame. Now to access a particular column of a data frame, there are two methods. One is the dot notation method. where we specify data frame dot and the column name. So it will display all the values of a particular column. Another method is to use the square bracket notation where we specify data frame and within the square bracket we specify the column name. So for example, we want to display this player column of df. So we say df and within the square bracket we give within single quotes we specify the column name. There are other two methods dot lock and dot ilock which are primarily used to access specific records or specific columns or a combination of these uh, while accessing the data. Okay, so .loc, which is .lock, it actually allows to access via the label names, and .iloc indicates the index location. That is, we specify the index location of a particular row label or column label to access the particular data we want to. So let's say we start with using .loc. So what we let's say our requirement is to select all the records of the country India. So we say df.loc and we specify the label IND. When we are using LOC, we have to specify the label value. So the label value we are specifying is IND, indicating India. So from the index, all those records where IND India is there. For example, if you see this record, this record, this record, so we have total 3 records. So these get selected. Tenulkar, Gavaskar, and Dravid. Now we can specify more than one labels. So we say we specify more than one in the form of a list actually. So we say df.loc and then we specify the labels in the form of a list that A US Australia and I and India. Then all the players which are there in the data frame belonging to corresponding to these index labels Australia and India, they get selected. Now we can also specify specific columns which we want to see. Now the way to access the specific columns is df.loc and square bracket. Now this colon indicates all the rows because we are applying filter on the basis of columns, not the rows. So basically we want to select all the rows for these particular columns. So we are giving colon. Colon means all the rows. This particular on the left hand side of the colon on the left hand side of this comma actually indicating the rows labels because we want to select everything from the rows, so we are giving colon here. And then on the right side of the comma we are specifying the columns in the form of a list which we want to see. So df.loc colon comma and then the list of the columns which we want to see. So it will display all the columns, it will display all the rows belonging to these two particular columns. So we are seeing player and centuries for all the records. Now we can put a constraint or we can put a filter on the row label as well as the column label. Let's say we want to select only 3 columns, that is player, number of centuries the player has made, and the batting average for all the players who belong to Australia and India only. So now we have two basically criteria to filter the data. One criteria is based on the columns and another criteria is based on the row index. So we have to specify like df.loc and then the first on the left no, no, on the left hand side of the comma belongs to row, so we have to specify the row filter criteria. So we are filtering for all those rows which belong to Australia and India index, and to the right of comma belongs to columns, so we are selecting these 3 columns. So what it means, select from df.loc, select all the records belonging to these two indexes or row labels, that is Australia and India. So Australia and India, all those records are selected, and after that give us only all those columns which are mentioned here in this list. So we will get only players, centuries, and batting average. So this way we can put a filter based on the row labels and column labels in a combined way. Now, iLock is another method to filter the criteria. The difference is between iLock and lock is that in iLock we have to specify the index location instead of the actual label name. So we can say df.ilock 0 to 3, so it will give you all the records where the row label is indexed from 0 to 3, and all the columns which are indexed from 0 to 4. So that's how we get the data. Now, because we usually want to access the data based on the label values or some logical criteria, so .loc is generally used more compared to .ilog. Yeah, so now let's continue further. Now, often there is a requirement to convert a data frame into a 2D array. So there are two ways to convert it. One is to use the to underscore numpy function. So we do like df, which is the data frame dot to underscore numpy, and the output that we get is in the form of array, a two-dimensional array which gets stored in ERR. Just to double confirm, we can check the shape of this array, ARR dot shape. We get 9 comma 5, so 9 indicates the number of rows and kind of a column. So where in a way it is it belongs to axis 0 and this belongs to axis 1 for this two-dimensional array. So we just print it out. So you see 9 rows, 1 2 3 4 5 6 7 8 9, and there are 5 columns. So the entire data frame data is actually got converted into a form of a two-dimensional array using df.to underscore numpy. The same thing we can achieve by using df.values. So if we say df.values, will get the same exactly same output. And so that's another way to convert data frame into a 2D array. Now to copy a data frame, we use simply copy function. Now default is deep equals to true. It means it creates a new object altogether. So if we say players equals to df.copy and deep equals to true, it will return all the data and indexes, and it will create a new data frame as players, and this will be a totally different data frame compared to df. So if we compare the IDs of players and df, it is false. It means they belong to different objects, that's why their IDs don't match. Now next is to reset the index. Now let's say uh, we want to include index as a part of our data columns, and we want index to come as like 0 1 2 3 and so on. So we can do data frame dot reset underscore index. So whatever index we had, for example in this case the index was the country name. Now that particular index gets included as additional column. So the index is now is getting represented here as index column, and its values, whatever the row labels were there, are its values. And now this is a part of a column, and we're just displaying the first 5 rows. And for the index, now the new index gets created, which starts from 0 1 2 3 and so on. Now this actually will display the output. It will not make any changes within the data frame. So if you want to make changes within the data frame, then we can specify in place equals to true. So if I say players dot reset underscore index in place equals to true, it will make changes within the players data frame. And then we display players dot head. We will see that okay, index uh, is now a part of the columns. Now since it is actually the country name, so we can rename this header index into appropriate column name, which like country. So like we'll say data frame dot rename. So we are using rename function, and within this we are specifying columns. The old column name, that is the existing column name, which is index, and it should be renamed to country. And in place equals to true means that the changes should be applied within the data frame. And then we are displaying this data frame players dot head, and if you see that, you will get index is renamed as country. Now if you want to change the index to some specific column, then we can use set underscore index. Now this data frame got created, it has index as 0 1 2 3 4. Now let's say if we want player name to become as the index of this data frame, then we say players dot set underscore index. So this will actually set a particular column as an index of data frame. So set underscore index, and the name of the column we are specifying here player, and in place equals to true means that okay, the changes should take place within the data frame. And then we will display players dot head. Then we say that okay, what the player name has moved from the column. Okay, it's not there in the columns anymore. It is actually now become index, and rest of the columns are coming as it is. So that way we can set index to a specific column we want to. We'll continue further in next tutorial. Thanks for now.